Everyone knows Charles Darwin as the father of evolution, so let's just jump right in with him. Darwin's theory of evolution begins with descent with modification. This basically states that over time and generations, the traits providing reproductive advantage become more and more common within the population. It can occur due to three things: variation in a trait, such as different beak sizes on finches; heritable traits, although Darwin didn't know about genetic variation at the time; and also natural selection. This states that traits that favor reproductive success and survival become more prevalent in the population. Now, mutations are a very important part of natural selection. They are the ultimate source of genetic variation within a population and are defined as any change in the sequence of bases in an organism's DNA. Most mutations are random, however, some are caused by the environment. The Hardy-Weinberg equation shows the relationship between allele frequencies and genotype frequencies, but only if 5 conditions are met. Before natural selection can occur, 3 conditions must be met: variation within a trait, heritability, and differential reproductive success. Directional selection is where physical traits at one extreme is favored. Disruptive selection is where physical traits at both extremes are favored. And stabilizing selection is where neither extremes are favored and intermediate phenotypes are the most successful. Sexual selection is recognized as a struggle between males for the possession of females. Sexual dimorphism is the difference in secondary characteristics between males and females. Intersexual selection is also known as selection or competition within the same sex. Intersexual selection has a lot to do with mate choice, where individuals of one sex are choosing and selecting their mates from the other sex. Females choose these exaggerated traits on the assumption that their healthy genes will be passed on to the offspring. A good example is the male peacock's brilliant feather display. Balancing selection is also known as the heterozygote advantage. An example of this is found in sickle cell anemia. In frequency-dependent selection, the fitness of a phenotype declines if it becomes too common in the population due to a strain on resources. So why can't natural selection lead to perfect organisms? Environments, predators, and the organism's competition are all evolving alongside of each other. This prevents either of them from getting ahead for too long. Evolution is also limited by historical constraints. Unless new mutations develop, natural selection is only building off of existing traits within the gene pool. It is important to remember that while natural selection does act on individuals, the population as a whole is what actually evolves.
Created using Powtoon.